Welcome to Manufacturing Talks with Jim Vinosky. Industry has a million cool stories, and Jim talks to the movers and shakers who are making them happen. Let's dive in.
Hey everybody, welcome back to Manufacturing Talks. I'm Jim Vinosky, your host. I'm really glad today to be joined by Ed McGinnis. He is the president and CEO of CURIO, here to talk about nuclear energy and nuclear waste reprocessing and all kinds of cool stuff nuclear. Welcome, Ed.
Pleasure to be here, Jim.
It's a pleasure to have you. Obviously, this is a pretty hot topic these days, so I'm really looking forward to diving into the details. We had an excellent discussion for our Forbes article that was published here recently. So yeah, definitely want to hear all the ins and outs here in this forum. Before we jump into what the company does, though, why don't you give us your background, how you got doing what you're doing today?
Sure. So I have been leading this company as president and CEO for a little over 3 years. Prior to that, I was with the U.S. Department of Energy for 30 years. First half of that 30-year period overall was spent in the national security side of the nuclear business, mostly. Nuclear nonproliferation in particular, and nuclear security to a lesser degree. The second half of my career, starting under the President Bush administration, I was asked to go over and work on the other side of the nuclear coin, if you will, from the national security side to the nuclear energy civilian side. And I did that in 2006. I was asked to help stand up a presidential initiative called Global Nuclear Energy Partnership, which I did. And I served as the Deputy Assistant Secretary for International Nuclear Policy and Cooperation for about 11 years. After that, I was asked to step up and serve as Assistant Secretary of Nuclear Energy Acting for about 2.5 years. That was as a career, but under the first Trump administration, initially under Secretary Rick Perry. Mm-hmm. And finally, the last major position I had within that 30-year government career was working at the White House, where I was asked to serve as the executive director of the President's Council of Advisors on Science and Technology. There you have it.
Excellent. Well, so obviously plenty of background for what you're doing today, right?
Yes. Yes, indeed.
Well, I'm sorry, go ahead.
Yes, indeed. And certainly at the end of my 30-year career at the Department of Energy, frankly, I was not sure if that was the White House was going to be my last big act. And but fate had other plans in mind. And so I serendipitously met the founder of the company I lead now, and he had a remarkable, extraordinary vision to really unlock the full potential of the nuclear energy sector in a way that I always thought would need to be done, and that is by solving the nuclear waste problem, and once and for all removing that biggest ball and chain to the nuclear sector, trying to progress and grow and expand. So it was an opportunity that I couldn't pass up. So that last big act in government wasn't the last big act in my career, and I'm very fortunate to have the opportunity to really provide legacy impact for the nuclear sector and legacy impact for future generations, not leaving them with a nuclear waste problem, but leaving them with the real full potential benefits of nuclear, not just energy, but nuclear technologies more broadly.
Yep. Yeah, and I agree. I couldn't be happier that wasn't your last act, because I think this new one is critical. And I was just bowled over talking to you about CURIO with what you have going on, because it's still so unknown, in the general public. We all know, or at least people who pay attention are aware of the nuclear waste challenge. And I don't think anyone really knows that there's so much going on to solve it. And then you guys have practical solutions here right on the horizon.
Indeed. It's been really refreshing and gratifying to see how thoughtful and how in-depth the public can be in understanding a complex issue like nuclear. It's not necessarily just complex because of the science behind it.
Right.
It's complex because of the social aspects, the historical, I would say, misconceptions that nuclear has had over the years. A large part of my job in the past 3 years, not just leading this company and bringing these innovative technologies for waste recycling, advanced nuclear reactors that will run off this so-called nuclear waste, and I'll certainly explain why it's not nuclear waste,
Yep.
and also extracting all these amazing, very, very important isotopes for society, for fighting cancer, other medical applications, industrial purposes, space-based, national security, all of which has a role in, from this perspective of the used nuclear fuel, so many of the isotopes that are needed are resident almost uniquely in the used nuclear fuel, so-called waste. So it's a real opportunity for us to explain to the public what that so-called nuclear waste is, which is anything but waste. And
Right.
I have been going around the country speaking to different state legislators, capitals, governors, local communities, explaining to them how valuable this used nuclear fuel is and that it's not nuclear waste. Because nuclear fuel in this country, when it is first put into a nuclear reactor, and by the way, we still have the largest nuclear sector in the world. And so we also therefore have the largest amount of used, or I would say most accurately described as slightly used nuclear fuel when it comes out of the reactor. And I say that because when the nuclear fuel is put into a nuclear reactor and run in the US for the first time, it runs for about 5 years. When they pull it out, you've only used about 4% of that energy value. There is enough energy value still resident in the sum total of that used nuclear fuel that's sitting around our country next to nuclear reactors after having been pulled out after 5 years or so to meet all of the US electricity needs for the next 150 years. That's not
amazing.
These are leading scientists from Idaho National Lab and others saying this.
Yep.
Yeah, that value is sitting there. We talk about, let's maximize the resources we have in our country for the good of energy security, for the good of affordability, jobs, economy, and geostrategically not being dependent on foreign suppliers, much less strategic adversaries. Yet, talk about digging up and maximizing, such as oil and gas with directional drilling and hydraulic fracturing, which was a remarkable feat that arrested this trajectory all the way back to the 1970s, where there was a slow but sure decline in American oil and gas production. And the view was peak oil. Where the US is done, we will never be able to achieve the levels of production. Yet, American technology, innovation, and know-how had something else to say. And it was in the 2000s with directional drilling and hydraulic fracturing, among other things, it completely changed the calculus. And suddenly, we are tapping resources under our feet that we never thought we could ever tap. Now, today in 2025, the United States is the largest oil and gas producer in the world, despite all the projections in the 70s. My point is nuclear is even better positioned to arrest that trajectory where we've been on this slow decline and a slow inevitable exit from the nuclear sector. Ironically, even though we essentially gave birth to the nuclear sector, and we were the original conceivers and developers of the technology that's being used today in the commercial sector, we're in an even better position to realize this amazing turnaround because we don't even have to dig to get this untapped resources that we haven't decided to tap. We literally have 90,000 metric tons equivalent to meet our U.S. electricity needs as indicated for the next 150 years, not to mention a plethora of other highly valuable isotopes for medical, industrial, space, and national security. Not even under our feet. It's sitting on top of the ground in casks that we've already packaged, sitting on the ground, nowhere to go because the federal government failed to pick up that material and throw it away because it's been the government policy all the way back to President Carter, where he put a moratorium in place for reprocessing, primarily because the technology used for processing back then was a very old process that had fundamental security flaws in it, a security Trojan horse, as I describe it, that made it just too easy for bad actors around the world to use that civilian technology for recycling or reprocessing and use it for an illicit nuclear weapons program. But so during that period of time, starting from Carter, when that moratorium was put in place, prior to that, the U.S. industry was reprocessing, even with that fundamentally security flawed process from a global nuclear proliferation perspective or non-proliferation. But when the president put that in place, that moratorium, it put these companies that are reprocessing in an impossible position. They couldn't proceed. They lost equivalent to billions of dollars because they were reprocessing before then. And they were planning to reprocess a lot more. So when the president put that moratorium in place, it essentially de facto made it waste because it said we can't recycle it. So all that material that ran through a reactor or it's going to run through a reactor once for 5 years, essentially it is waste. But it's a function of government policy that made it waste, not because it is waste. It's technically slightly used nuclear fuel because you've only used about 4%. It may be in a highly radioactive state when you pull it out after 5 years, but that does not mean that it doesn't have tremendous value still resident. And really, I would argue that one of the additional nails in the coffin on the issue of recycling and having a sustainable recycling, closed fuel, closed loop approach for the U.S. nuclear sector was when Congress ironically passed the Nuclear Waste Policy Act for good intentions, but it essentially said that the U.S. Department of Energy will take that used nuclear fuel, that de facto waste sitting on the pads at the nuclear reactors, and take it and then permanently dispose of it. And that's where you hear about Yucca Mountain, right?
Yep.
And that is politically unworkable for both sides. No one is, I don't think anybody is realistically thinking that would ever restart. But essentially, we have all the way up to present day, all this material that's been building up. We're adding 2,000 or so metric tons of this slightly used nuclear fuel that by definition of government policy is being treated as waste. We're adding 2,000 metric tons a year just with the current fleet, not even factoring in new reactors that are likely going to be built. Therein lies one of the key markets for our company, my company named CURIO, and that is to be a problem solver, a liability reducer, and a service provider of clean, affordable electricity, of vitally needed isotopes that are needed for fighting cancer, industrial space-based power sources, national security, you name it. And to provide that, also at the same time, reducing and solving the nuclear waste problem by reducing the amount of waste to only about 3 to 4% of that original waste, which is what our technology, our recycling is designed to do. So the current recycling around the world, Russia, France, Japan, others, they're all state-owned companies, and they're all using a 70, 80-year-old vintage technology called PUREX, which is the process that I mentioned that President Carter, stopped through an executive action for a moratorium. That process has fundamental problems that I would argue are the reasons why you don't see that type of reprocessing in the U.S. today. Number one, the security problem, like I said. It's called PUREX for a reason, because that process requires pulling out a pure stream of plutonium in order to reprocess that fuel. And that's what everybody does in France and others. France has the largest reprocessing facility in the world called La Hague in northern France. And that facility, they literally have to maintain hundreds of metric tons of plutonium-239 weapons usable material just to keep balance of the operation of the plant. Now, it may be secure in France, but you can imagine the security concerns if that type of facility proliferates and is replicated around the world. Well, it has been replicated. We know that. Whether it is North Korea, that's how they got their first material for a nuclear bomb through reprocessing their research reactor fuel, using that process. Whether it's India, reprocessing, whether it is Pakistan and others. So the fact is, reprocessing with that technology has been an issue, and is one of the reasons why our company does not believe that a PUREX-based process would be acceptable by the policymakers that are concerned about nuclear proliferation. The second of three reasons why I don't believe there's reprocessing in this country is because that technology, the PUREX process, has inherently environmental problems in it. What I mean by that is the PUREX process uses a nitric acid based process to get to reprocess that material. So they take these 14-foot high tall fuel assemblies, they chop them up, and they put them in a bath of nitric acid to dissolve it to extract in an aqueous process limited amounts of isotopes that have value, plutonium and uranium. We're going to extract much more than that, but I'll explain that in a second. By doing that, Jim, when you're injecting additional high-level or aqueous nitric acid into that process, you're actually creating more high-level waste than you even started with.
Wow.
Then you're having to deal with all that waste, spend money on it, deal with the waste management of that. So that is a fundamental problem. And there are many stakeholders that would vehemently oppose any PUREX-based plant in the United States because of the environmental impact of generating more high-level waste than you even started. And then third, economically, these are all state-owned companies around the world. And so they're not set up like a private company where they're hardwired to maximize the value of the product, minimize overhead, maximize return on investment. So what we have done with CURIO, and the reason why I did leave the federal government for that second act, is because of the vision and the incredible diligence of the founders of my company. What they did is they concluded, absolutely, one person's waste, another person's treasure. This material is an incredible, valuable resource, and concluded and found out why we're not reprocessing primarily in the US, primarily. And there are three reasons which led us to develop our own fully patented recycling process that is environmentally very responsible and that has built-in security and that it is a strong, robust economic business model. So the first, for the environmental, we eliminated in our recycling process the use of nitric acid, and we use a superheated process, which is essentially a dry process, and an electrolysis process, using the latest modularity, the latest compactness, the latest autonomous types of techniques used for recycling.
Mhm.
All these other facilities around the world that they've been around for decades. They've sunk 20, $30 billion into it. They're some size of a small city. It's extremely difficult for them to pivot away from that PUREX process.
Right.
So advantage of a company like ours is a startup, we can start from scratch, right? So we start from scratch and brought in the best of the best. So
Yep.
our process, number one, is environmentally responsible because we are using this dry and electrolysis type process that literally, Jim, allows us to reduce the amount of original high-level waste in those fuel assemblies that we process down to about 3 to 4% of the original waste. So we will, in our process, because we're not using a nitric acid process, we are going to be able to reduce by 96+% the original high-level radioactive material waste that's going to have to be permanently disposed of. And on top of it, the process that we are doing will actually result in that remaining 3 to 4% of that waste only needing to be permanently geologically disposed of safely from human contact for about 300 years. That may sound like a lot, but it's not compared to the amount of time that the unrecycled spent nuclear fuel, used nuclear fuel treated as waste sitting around our sites around the country are going to have to be securely stored. The Nuclear Regulatory Commission already has a requirement that if you don't recycle this material, or the material as is coming out once through a reactor, will have to be securely stored from human contact for 10,000 years, with requirements up to 1,000,000 years. That's almost impossible to put your mind around, but that's what we're dealing with if you don't recycle it. So we're going to reduce the problem down to about 3 to 4% and only 300-year problem, and then we're going to extract all the other valuable isotopes. So the environmental part is huge, and it translates into economic advantages because we don't have to spend as a company all that money to deal with that additional waste that came from the injection of nitric acid. Number two, we have plugged that Trojan horse from a security problem. We never pull out a pure stream of plutonium. We only pull it out co-extracted with other transuranics, what we call, and other fission products that will essentially put a security blanket barrier around that plutonium so that it would be extremely difficult for bad actors to get to that plutonium, yet we will still be able to use it as a very high performance fuel in the civilian sector. In fact, our 2 reactors are going to be powered by that fuel. And then lastly, the economics. We took a very different approach. Our approach is that we want to pull out every isotope that has value in that so-called nuclear waste. We have already identified over 10 isotopes and precious metals that we're going to extract. We already have market pricing for it, and we already have offtake agreements or indicators for virtually all of those. So examples of isotopes that are in there, of course, you have the isotopes for fuel. I mentioned we have enough remaining fuel in that used nuclear fuel to meet our electricity needs for the next 150 years.
Right.
That's based on 2 isotopes we're going to pull out. One is the uranium isotope, uranium-235. We will extract that. It will be enrichment ready in a gaseous form. And so we will eliminate the need in our process for the fuel we're drawing out to mine it and to have to convert it. And so we're going to be extracting it where it's going to be enrichment ready. And so that is going to be feedstock for U.S. nuclear fuel in our reactors today. So right now we still are dependent on Russia for over 20% of our uranium-based nuclear fuel. And that is still to this day, despite the previous president signing a legislation banning Russian uranium, but that had a 3-year waiver period because they wanted to avoid any type of impacts like rolling brownouts if that was cut off too quickly. Shows how precarious our situation has been,
Right.
depending on foreign suppliers of uranium. In fact, we are almost 100% dependent on foreign suppliers, even today, of our nuclear fuel. And nuclear provides 20% of our nation's our electricity, nearly 20%. So that is not a good thing. That's not reflective of a strong energy security portfolio. Granted, one of the main we have one nuclear fuel producer in the U.S., an enricher, Urenco, so it is European, but nonetheless, they're foreign providers. We need domestic sources, and if we recycle and we extract this uranium, we are providing a substantial portion of our uranium from an all-American company, from all-American resources, and not even having to mine that material for that purpose.
Yeah.
We will be able to provide with our recycling facility as much as a third or more of our annual nuclear fuel requirement from our waste processing. So it's a real win-win. So environmentally, security-wise, and then economic robustness by essentially being a commodity extractor are keys. A couple of other examples, and I'll wrap this up on describing our recycling technology, which we call New Cycle, is that we'll pull out of those 10 or so isotopes, the uranium, we call it UF6, uranium-235. We will pull out also the second fuel source that goes into that estimate of 150 years of electricity extracted from that remaining value is the plutonium. So we will pull out plutonium as well as uranium. So we will be a fuel provider of two types of fuel: uranium-based fuel and then plutonium-based fuel. And we actually believe the plutonium-based fuel has incredible upside market opportunity because it has a higher density of power generation and lower weight ratio than uranium. That means we can develop and design a reactor, small modular reactor, which we have. It's called HOPE, 250 megawatt to 300 megawatt electric. Our reactor we can design to be approximately a third the size or a half the size of a uranium-based reactor generating the same power, because plutonium has a higher density of power and lower weight ratio. The only thing is, where do you get the plutonium, and where do you get it where it has a nice security blanket built in? You can't find it. And certainly the US companies don't have it. How do you get it? You have to recycle it. Why? Because plutonium is only generated essentially in a man-made process. Plutonium is not a naturally occurring, certainly in general, material that you dig out of the ground. You harvest it from uranium that had been mined, enriched, and fissioned. And during that fissioning process, that's where plutonium is generated. Then you harvest it from that. That's how the fission process for that 5-year period also generates many of those other isotopes that are sorely needed. So we're going to be a fuel provider for uranium-based and plutonium-based reactors. And then we will also be isotope providers for medical and industrial, like krypton-85. Krypton-85 is needed for medical imaging. It's needed for national security purposes, detecting leaks in reactor pressure vessels for the Navy, for example. Who is the only supplier in the world of krypton-85? And there's only one. It's Russia. Why? Because they reprocess from mine. And so they have a monopoly supply on a vitally important isotope, krypton-85, which is resident in our used nuclear fuel in large quantities in the US. It's a no-brainer. We have a market value in that used nuclear fuel, so-called waste. And I'll just leave another couple of examples of valuable isotopes. You've got strontium-90, which is very much needed for these advanced nanodiamond batteries that are being developed now. And large quantities are in this used nuclear fuel. We have offtake agreements with 2 companies now for that. And how many people realize there are some non-radioactive elements that are generated during the fissioning process of that nuclear fuel in a reactor that generates some of the most valuable metals in the world. In fact, the most valuable metal in the world is rhodium. That's why you see some theft of catalytic converters, very, very small amount of rhodium in there. Rhodium is the most expensive metal in the world. We will be able to provide large portion of the entire global demand of rhodium simply by extracting it from our used nuclear fuel. So that's sort of the overall value proposition and our approach to getting into the market. So providing that technology that is sensitive to the environment and the concerns about generating more waste, that is sensitive to the security and proliferation and plugging that Trojan horse, and that is also not going to put this on the backs of the taxpayer and government entities anymore, and have the private sector come in once and for all, not unlike SpaceX when they came in the 2000s and they went head to head against NASA and other international giants in the space industry and absolutely transformed it. So it shows the ability of a startup company, how it can have transformative effects. And that's what we are intending to do. And lastly, it's not just the recycling. Our recycling, called New Cycle, is a backbone technology. And that's how we're getting into the market, unlike virtually any of the other US nuclear companies that are trying to get into the market. Yet we are going to also bring in our own advanced small modular reactor fueled by our own fuel, and a micro reactor fueled by our recycled fuel. And then we'll be also a major isotope producer of medical and industrial space-based others. And we will also therefore be a waste disposal company, because we will be bringing down the waste to about 3 to 4%. And then you can take 3 to 4% and easily dispose it in a deep borehole, standard industry 12-inch, 12 to 18,000 feet in the ground. You probably wouldn't need more than 4 to 5 or 6 of them. That's an end-to-end comprehensive solution that we're going to be able to provide to customers that they don't have right now. No U.S. nuclear utility has that offer of a reactor, the fuel, secure fuel, environmentally sustainable extracted fuel, waste disposition, all in one.
And it's important to note too, your reprocessing, your new fuel, is usable by existing reactors. And so as you get into the market on that, you have customers for that immediately. Then at the same time, you're developing your reactors to eventually use your own fuel that you've reprocessed. So
absolutely, Jim. And if I could just make a point on that, our recycling, our uranium feedstock will be able to provide the feedstock for fuel for all the reactors in the U.S., all types. There are 2 types, pressurized water reactor and a boiling water reactor. We are reactor agnostic. And secondly, that input will also, uranium, ours, will be able to be used for advanced reactors with the so-called HALEU, this advanced fuel, higher enrichment for the advanced reactors coming in. We will be able to provide that feedstock as well. Secondly, for the plutonium, that will be able to be available for advanced reactors. And we're even looking at that plutonium fuel that could be used in current reactors. So, and finally, we have agreements with some of the largest nuclear utilities in the country right now. And one is public facing with Energy Northwest Columbia Generation Station in Washington State. That's the utility that Amazon is now partnered with, where that utility, Energy Northwest, is now planning to order a number of these advanced small modular reactors called the design, or the reactor company is called X Energy. That's the company that Amazon invested in. And we actually are already conducting feasibility studies of being able to recycle that fuel and then sell back fuel to them from that recycled fuel. So
Yep.
we're very, very confident of the substantial markets awaiting a company like ours that's going to get into the market through what we call the back end, through recycling.
Yep.
We expect to be in the early 2030s to have our full suite of commercial technologies.
Yeah, you just anticipated my question.
Yeah.
Specifically, you've got the reprocessing. When do you see that being fully commercialized? And then what are you thinking as far as the reactors?
We plan to have our technology fully commercialized at full commercial capacity no later than about 2033 to 2035, so in about 8 years or so. However, we're going to scale up. So we will actually have operating recycling facilities, we expect, within the next 4 to 5 years. In fact, we're going to scale it up and break it down to 2 to 3 different scale ups before we go to our full commercial, or full commercials more than one. And that is, we are almost done with our lab scale demonstration of this new cycle recycling. It's a 3-year process, and we've already finished 2 years successfully. We're partnered with the U.S. Department of Energy, 4 national labs in particular, and the Department of Energy is actually funding us 80% of this project. That's how interested they are in it. We end up, by next year, within less than a year, we will have completed our lab scale demonstration of this unique recycling technology with actual commercial use nuclear fuel. Concurrently, we're going to then quickly scale up to a larger recycling facility and have that done in about 1.5 to 2 years after that. So in about 3 years, we expect to have a scaled up version. Once we have the scaled up version, we will be able to pull out market quantities of that material. So even though the full commercial facility we expect to be ready 2033 or 2034, with our small modular reactor advanced and our micro, we will actually be able to provide sorely needed isotopes from that recycling within the next 3 years or so. It's not unlike SpaceX again. We think that's a very effective model. SpaceX did not go from paper design of the Starship to building the Starship. They scaled up, they did engineering by design. They started with the Grasshopper, then built the Falcon 9. They started with the Starhopper, then went for the Starship, right? That's our approach. We believe that is the most effective way to de-risk something as ambitious as this technologically, and it gives us the greatest likelihood of success.
Excellent stuff. Okay. Any last thoughts before we wrap up?
Just want to say thank you for helping shed light on this important issue. As indicated at the beginning of our discussion, I think it's very important that we convey as much as possible, as clearly as possible, to the public the actual situation of the nuclear sector and the value propositions and the opportunities for us to really unlock the nuclear sector and set it up in a way where one doesn't have to have this Faustian bargain or decision where if you access nuclear, you have to also accept this nuclear waste legacy ball and chain.
Right.
We want to win-win. We want you to be able to access nuclear and do it in a way where it's environmentally sustainable and responsible, where we have a clear way of managing the so-called waste and disposing of it, not passing it on to the next future generations. So thank you again for helping shed light on this, and we appreciate all the time you've given me.
Absolutely. Yeah. Thank you, Ed. I can't tell you how excited I am about it. So I'm really happy to help spread the word because I agree. I think, getting this knowledge out in front of people, nuclear is already getting a resurgence just because it makes so much sense. And
Yes.
so getting people to understand that there's these kinds of solutions to the problems they've heard about for decades is extremely exciting. So yeah, thank you so much for bringing it to us and sharing it with everyone out there.
Great, Jim. You have a great day, and hopefully we'll be able to talk further in the future.
Yep, sounds good. Would love to get some updates. And as always, thanks to those of you in the audience. You're why we're here, and we're here every Tuesday. So tune back in. We'll have another show. I can't promise every show is going to be as incredibly informative and enlightening as what Ed brought us today, but they're all going to be at least a little informative and enlightening. So tune in. We'll be here. Jim Vinosky from Manufacturing Talks signing off. So long.
All the best.
Thanks for tuning in to Manufacturing Talks with Jim Vinosky. Watch for new episodes dropping every Tuesday. And don't forget to like, share, comment, and subscribe.